Okay, welcome to this new online lecture. I repeat that during this lecture I have student online, so student will be asking me some question, and I will be replying. So anytime I will have a new question, I will repeat the question so that you can understand the question. Good, so let's start. Last time we solved this MCQ until number 7, and so we start by number 7. So the indefinite integral given by the integral of sine of 2x over 1 plus sine square of x in dx takes value. So here we are asked to compute these indefinite integrals. Okay, so it is the integral of the sine of 2x divided by 1 plus the sine square of x in dx. Nice. We remember this fundamental formula that says that the integral of f prime over f in dx is actually equal to the logarithm of the absolute value of f plus a constant, right? This is a formula that we saw in the previous solving some MCQs some days ago. Okay, so but another fundamental formula to remind is that actually if you the derivative of 1 plus sine square, first let me write this derivative, then I will remind the fundamental formula. The derivative of this function is nothing else than 2 times the cos of x times the sine of x. Okay, but now this is the fundamental formula. You know that 2 sine of x cosine of x is actually the sine of 2x. Okay, that means that what am I saying is that the derivative of the denominator here is actually the numerator. The derivative of this denominator gave off sine of 2x. So in fact this integral here, let me go back with it, will be, so the integral of sine of 2x over 1 plus sine square of x, okay, is equal to the integral of f prime over f, where f is 1 plus sine square of x. Okay, so this integral here will give us the logarithm of the absolute value of 1 plus sine square of x plus c. But as you can see, this is a positive quantity, so it doesn't mind if you put the absolute value or not. It will be then the logarithm of 1 plus sine square of x just plus c. We go back in the stuff and we see that the answer is E. No, excuse me, the answer is C. Alright, okay, so the question of my student is, he didn't understand how did we move from how did I prove that the derivative of the denominator is equal to the numerator. Let's do again. The denominator is 1 plus sine square of x, right? And I remind, this is the formula I'm going to write now is a trigonometric formula. This trigonometric formula says that the 2 times the cosine of x times the sine of x always give the sine of 2x. Is that clear? So this is a trigonometric formula. Now, what is the denominator prime? If I do d prime, the derivative of 1 is 0, right? So it will be 0 plus the derivative of sine square x. But what is the derivative of sine square? Remember that the derivative of f square is 2 times f prime times f. So the derivative of sine square will be 2 times, what is it, f prime? F prime, the derivative of sine x is cosine x. It will be 2 cosine x multiplied by sine x, right? And from the formula written in red here, from this formula, this is sine 2x. And if you have a look, sine 2x is exactly the numerator. Is that clear now? Good. Can I move to number 8? Now we move to MCQ number 8. The integral, this integral here, the integral of 1 over x squared plus 9 in dx is equal to, okay, it's time to, when you look at this integral, it's clear that, let's go back to a new page, just clean the bar. So we have the integral of 1 over x squared plus 9 in dx. If you look at this integral, it's clear that this integral is not f prime over f, because the derivative of the denominator is 2x, and unfortunately you cannot put 2x here and divide by 2x, because the x, you cannot move the x out. So that is, it means that as it's not this form, okay, and it's not even the form f prime times f to power n, so there is no way to use these two formulas. But now I will create a new formula that says that I will remind a new formula that says that the integral of f prime over 1 plus x square, f square, I mean, let me write it back, let me write it again, I mean, it says that the integral of f prime over 1 plus s square in dx is actually the arctan of f plus c, okay? Is that clear, this? Nice. So we have our function, but if one have a look, the function is not exactly, let's say that, going back here, this is the integral. So we write back the integral, it's 1 over x squared plus 9 in dx, but I want to reach this stuff, this formula. So first of all, it's clear that I can do like this, it's the same, right? Ah yes, it's 9 plus x squared, I said 1, it's the same now, right? Nice. If I want to reach 1 plus f squared, I typically need to move this 9 out. So this could be the integral of 1 over 9 into 1 plus x squared over 9, right? dx. That I should write that this 9, I can bring it out, it will be 1 over 9 integral of what over 1 plus, I can write this like this. Now you see that more or less I have my 1 plus f square. What is f square here? F square for sure will be, this is f, right? This is my f. So my f is x over 3. You see that I have 1 plus 1 over f square, but I don't have f prime, because f prime here, how much is it? But if f of x is x over 3, what will be f prime of x? F prime of x will be 1 over 3, basically, because if you have f of x equal to 2x, then f prime is 2. X over 3 is like 1 over 3x. So f prime is 1 over 3. So I still need to get 1 over 3 up, because here the formula is f prime over 1 plus f squared. So coming back, so we reach that our integral is equal to 1 over 1 plus x over 3 all square. That this is 1 over 9 out. Now we can write like this one. We can write this like 3 over 3 all divided by 1 plus x over 3 all square. There is the 1 over 9 out. This I just write 1 like 3 over 3. Now when I write 3 over 3, I can bring 1 3 out, like this is equal to 3 over 9, yes, integral of 1 over 3 divided by 1 plus x over 3 square. But now if you have a look to this integral, this is exactly the integral of f prime over 1 plus f squared. That is r tan of x. So this will be 3 over 9 multiplied by r tan of, we say r tan of f x over 3 plus c. Thus we can write it like 1 over 3, that is 3 over 9, r tan of x over 3 plus c. So here is the result of this integral. Okay, is that clear? Okay, this will be the end for this section. We will continue the next section.